10th CBSE Mathematics, Chapter Quadratic Equations. After watching this video, you will understand to find the nature of roots of the quadratic equation. A quadratic equation is of the form ax square plus bx plus c equal to 0. If we want to find the roots of this quadratic equation, then we can use the quadratic formula, which is minus b plus or minus square root of b square minus 4ac upon 2a. Here b square minus 4ac is the discriminant. The discriminant determines the nature of the roots of the quadratic equation without actually solving it. Now the discriminant b square minus 4ac can either be less than 0, equal to 0 or greater than 0. Let us take the first case when b square minus 4ac is greater than 0. That means x will be equal to minus b plus root of b square minus 4ac upon 2a, or x will be equal to minus b minus square root of b square minus 4ac upon 2a. That means we will have two real and distinct roots. Now if b square minus 4ac is less than 0, then we will have no real roots because the roots will be imaginary or complex. Now if we have b square minus 4ac as equal to 0, that means x is equal to minus b plus or minus 0 divided by 2a, which means x is equal to minus b by 2a or x is equal to minus b by 2a. So we have two roots and the two roots are equal, and each root will be equal to minus b by 2a. Let us now quickly recap about the nature of roots of the quadratic equation. If b square minus 4ac is greater than 0, then the roots of the quadratic equation are real and distinct. There are two roots and they are minus b plus square root of b square minus 4ac upon 2a and minus b minus square root of b square minus 4ac upon 2a. If b square minus 4ac is less than 0, then the quadratic equation has no real roots because the roots are imaginary or complex. If b square minus 4ac is equal to 0, then we have two real and equal roots. Each root will be equal to minus b by 2a. Let us understand this concept better by solving some examples. Let us find the nature of the roots of the quadratic equation 4x square minus 12x plus 9 equal to 0 and find the roots of the equation. Now let us compare this equation with the standard form of the quadratic equation ax square plus bx plus c equal to 0. So we have a as equal to 4, b as equal to minus 12 and c as equal to 9. We know that the discriminant is given by b square minus 4ac and this determines the nature of the roots of the quadratic equation. So let us substitute the values of a, b, c in b square minus 4ac. So we get minus 12 the whole square minus 4 into 9. So 144 minus 144. So b square minus 4ac is equal to 0. And because b square minus 4ac is equal to 0, we know that the quadratic equation has two equal and real roots and each root is given by minus b by 2a. So we substitute the values of b and a from the values we already found. So we have minus of minus 12 upon 2 into 4. Simplifying this, we get each root as equal to 3 by 2. So we have two roots, 3 by 2 and 3 by 2. Hence the roots of the quadratic equation 4x square minus 12x plus 9 equal to 0 are 3 by 2 and 3 by 2. Let us find the discriminant of the quadratic equation x square minus 3x plus 10 equal to 0 and hence find the nature of its roots. Let us compare this equation with the standard form of the quadratic equation ax square plus bx plus c equal to 0. Here a is equal to 1, b is equal to minus 3 and c is equal to 10. We know that the discriminant of the quadratic equation is b square minus 4ac. This determines the nature of the roots of the quadratic equation. Let us substitute the values of a, b and c in b square minus 4ac. We get minus 3 the whole square minus 4 into 1 into 10. So we have 9 minus 40. b square minus 4ac is equal to minus 31. Now, if we had to find the roots of the quadratic equation x square minus 3x plus 10 is equal to 0, then we can use the quadratic formula x is equal to minus b plus or minus square root of b square minus 4ac upon 2a. In this, the value of b square minus 4ac is already equal to minus 31, we have found out. So, square root of minus 31 will be a imaginary or a complex number. Hence, we say that if b square minus 4ac is less than 0, then the quadratic equation has no real roots. Let us now take a real life example where the perimeter of a rectangular field is 82 meters. Its area is given to us as 400 square meters. Is this situation possible? If it is possible, then let us find the dimensions of the garden. The data given to us is that the perimeter of the rectangular field is equal to 82 meters. It is also given to us that the area is equal to 400 square meters. Now we know that the perimeter of a rectangle is given by 2 into L plus B. That means 82 is equal to 2 into L plus B. That means we can simplify this and write L plus B as equal to 41. Let us mark this as equation 1. Area is given to us as 400 and area of a rectangular field is equal to L into B. That means 400 equal to L into B, or we can say B as equal to 400 divided by L. Let us substitute the value of B from equation 2 in equation 1 and we will get 41 equal to L plus 400 divided by L. Let us take the LCM on the right side of the equation. So we have L as the LCM. We'll get L square plus 400. Now cross multiplying, we get 41L equal to L square plus 400. We can see that this equation is not in the standard form of the quadratic equation. Let us rearrange the terms. We have minus L square plus 41L minus 400 equal to 0. Dividing this equation throughout by minus 1, we get L square minus 41L plus 400 equal to 0. When we compare this with the standard form of the quadratic equation ax square plus bx plus c equal to 0, we have our a as equal to 1, b as equal to minus 41 and c as equal to 400. If the equation has real roots, only then can we find the dimensions of the field. The discriminant decides the nature of the roots of the quadratic equation. The discriminant is b square minus 4ac. Now let us substitute the values of ABC in b square minus 4ac. We get minus 41 the whole square minus 4 into 1 into 400. Solving this, we get b square minus 4ac as equal to 81. Since 81 is greater than 0, so we can say that b square minus 4ac is greater than 0. So this equation has two real and distinct roots. Now let us also find the roots of this equation so that we can find the dimension of the field. Now to do this, we know that the roots of the equation will be given by the formula L equal to minus b plus square root of b square minus 4ac upon 2a, or L is equal to minus b minus square root of b square minus 4ac upon 2a. Now let us substitute the values of a, b and c in this. We get L is equal to minus of minus 41 plus square root of b square minus 4ac, we already calculated it as 81. So square root of 81 divided by 2 into 1, or L is equal to minus of minus 41 minus square root of 81 divided by 2 into 1. We'll get 41 plus square root of 81 is given as 9 divided by 2, or L is equal to 41 minus 9 divided by 2. So we have L as equal to 50 divided by 2, which is 25, or L is equal to 32 divided by 2, which is 16. Now we have two positive roots, 25 and 16. So let us calculate the breadth. If length equal to 25, then the breadth will be equal to 400 divided by 25, which is 16. If the length is equal to 16, then the breadth is equal to 400 divided by 16, which is 25. So if the length is 25, then the breadth will be equal to 16. And if the length is equal to 16, then the breadth will be equal to 25. Hence the dimensions of the rectangular field are 16 by 25 meters or 25 by 16 meters. In this video, we have learnt that the discriminant determines the nature of the roots of the quadratic equation.